Hello everybody and welcome to Statistically Speaking. Today we're gonna look at central tendency. And what central tendency is pretty much where the data is centered. Like where is the center point? And that can be defined in different ways, and three of the most common ways are the mean, the median, and the mode. I have done videos about mean and median on their own, so I recommend looking at those if you're not familiar with how to calculate those or what they are and stuff like that. But today we're gonna talk about mode, and then we're gonna compare these to see how do they look compared to each other depending on how the data looks. So we're gonna start looking at mode first. So what is the mode? Well, the mode is the observation that is most common. So in this example, let's say we throw a dice. So we have the six-sided dice and we have the different faces it can show. And then we also note the frequency. How many times did we get a 1, how many times did we get a 2, and so on. And we'll see here, well, we have 15, 14, 16, and so on. And the mode is the X that has the highest frequency. So, if we look here, what is the highest number? Well, the highest number here, it is 17. So the mode in this case then will be 5. Because, well, we have 17 fives. And what would happen if we would say, let's say that the 3 wasn't 16, but instead it was also 17. So we have 2 x's, that is 17, which is the highest number still. Well, in this case we will actually have that the mode is both. It is both 3 and 5. So in this case the mode would be 3 and 5. And that is what differentiates mode from median and mean, because those can only have one number. It is the middle point or the average of everything. But a mode can be multiple. And we will see this now when we compare the difference. So here I have prepared 6 different graphs. And we'll see, well, we have one that is just a box, also known as uniform. We have something that is similar to a normal distribution. We have just a bar graph. We have right skewed, also known as positive skewed, because it is skewed toward the right side, the more positive numbers. And we have a left skewed or negative skewed, because it's skewed towards left, where the more negative numbers lies. And then we have a distribution that is a little more special. So let's start with our uniform case. Uniform distribution is very special because it is always the same height in the interval that is interesting. So when we're then gonna look at what are the mean and what are the median and what are the mode for a uniform, we see something special, because we know that the median is where 50% of everything is below, and if we would think that this is 100%, then 50%, well, it would naturally be in the middle, so somewhere along here. That would be our median. And I did not write this in the video where I talked about median, but median can be denoted as X with a wave above it. And we know that the mean, well, that is the average point. But if we would take the average of these, we would see, well, it's the same point. X bar, the mean, would also be at that point. And then we come to the case where we have the mode. Well, the mode is where we have the most observations for a value. But uniform is special because it's the same everywhere. And that means that the mode in a uniform distribution, well, it's everything here. Everything between the starting point of our uniform and the ending point, well, that is our mode. So it's a pretty special case, but, well, that's how that looks. And then if we would look at our more symmetrical normal distribution graph, or what we can call it, well, this is supposed to be symmetrical, meaning that the middle point, so we have here, that is the point that divides our data in equal parts. So we have 50% below and 50% above, meaning this will be our median. And it would also be our mean, our x-bar. Because it is symmetrical, this would weight just as much as this, which would make that our average is gonna be the middle. And then we have mode. Well, the mode is the highest point in a graph, we can say. It's where the most observations lie and all that, meaning the highest point. Well, the highest point in this case, well, it's the same point. It's the highest point here. So this would also be our mode. And now we come to the bar graph. Well, in a bar graph, if we have a mean, will depend on if the bar graph shows us for numbers. Like if we would throw a dice, this could be dice rolls, 6-sided dice, then we would be able to calculate what the average is. And it would be somewhere along here, maybe a little more towards there. I don't know. It would depend on what numbers we have and stuff like that. But a bar graph could also be intervals. So we could have 1 to 3, and then 4 to 6, and so on. Well, we could calculate a mean where we just take the middle point or something along those lines and calculate that. But we don't have a clear way of this is the way to do it when we have intervals. We can, however, do the median. We just sort them like normal. So this is the interval that has the smallest numbers. This has the bigger number, and then that has bigger, and so on. And we would just see, okay, which bar has the middle observation. And in this case, I would believe that this bar would be our median. And we also have the mode. We know that the mode is the highest point in our data, and we can clearly see that this bar is higher than the others. So this would also be our mode. But we also have the special case where these bars does not show numbers. It might show, let's say, professions. So we have nurses, we have doctors, we have statisticians, and so on. And then, well, we can't take an average of different professions. The median is also very hard because we can't sort them in any way. So the only central tendency we would be able to use in that case would be the mode. Because the mode doesn't really care about that, it only cares about what is the highest. Where is the central part of everything? So it all depends on how does the data look. Next is our right skewed, our positive skewed. If we would start with the median, we don't have that clear at this point. Where is the median in this case? Because it's not symmetrical, I can't find it just that easy. But I think maybe somewhere along here. This area, that seems about right to be the same area as this. Maybe a little more towards the right. But somewhere along there would be our median. The mean, however, is more sensitive to extreme observations. So these observations down here, we don't have many of them, but they are much higher than the ones here. These would bring us more towards that side, meaning that the mean would be at that side of the median. How far, it would depend on how far are the graph going. And then we will check the mode. Well, the mode is, like I said, highest point. So here we would have the mode. And then let's look at the flip side of this, the left skewed, negative skewed. Well, just like before, well, what divides the data in two parts? Well, it would probably along here. This would probably be our median, dividing 50% at each side. And just like in the last case, that observations that were extreme towards the right would skew the mean towards that side, the same is true when it is skewed towards negative. These numbers would push the mean towards that side. So, somewhere along there would be our mean. And the mode, well, it is just this highest point again. So we see that the positive and negative skews, they're pretty similar, they're just different ways they're turned. And then let's look at this last graph. This is a more special case, but we can see that it looks pretty symmetrical. So we probably here in the middle, both have the median and the mean. But then the mode. Well, I said before that the mode is the highest point, and that is not actually true. The mode commonly actually refers to all the local maximums. What are the local maximums? Well, we can see that if we look here, we have a curve, and here we have a curve, and here we have a curve where it changes which direction it's going, if it's going up or it's going down. And the local maximums is when it's gone up and then starts to go down. So we see here, we have 3 of these. And the maximum is at this highest point of these. So we will have that all of these points are gonna be the mode. So even if this is the highest point, these are still considered modes. And when we have like this, that we have more than one mode, that is called multimodal. And the same when we just have one, it is called unimodal. So that was some explanation about central tendencies and how we can compare them in different scenarios.